Hello out there, welcome today. So the focus of this lesson today will be focused on application of counting principle. What is application of counting principle? Okay. So previously we've learned the counting principle, the fundamental counting principle. How many ways can we arrange boys and girls in a cinema if there's 7 chairs in a row? Something of that nature. And we've looked at examples where we look at car registrations in Gauteng and how many car registration we can form in Gauteng. And remember that vowels and Q was not used. So now this section, we're going to look at how can we really apply that? Why is counting principle so useful? But the application will be based on probability. Okay, that's what counting principle. And remember to work with us there, have a pen and paper, and really focus and push some of the problem with us. Okay, fantastic. Okay, now what is the question? The question is, what is the probability of contracting COVID-19 at school? Okay, so the likelihood of getting COVID-19 at school, if you social distance and you're using a mask, that's very low. But to actually calculate the likelihood of that, you will need to collect data and see how many people are actually getting COVID-19 and when one can estimate the likelihood of getting COVID-19. Okay, fantastic. Now, let's look at some of what you're going to focus on. We did say we're going to look at application of counting principle, but we'll look at problems. Relating to probability, we'll revise the fundamental principle of counting. Then look at arrangement and example and repetition and choice with repetition. It's very important that you have mastered your counting principle because you're going to use the fundamental of counting principle to calculate some probability. So that's application of that. Are we together? Okay. So let's look at some of keywords. What is arrangement, counting, and repetition? So arrangement is when I arrange, sort things out, that's arrangement. And counting in this, what are we talking about? You know how to count, we can count from 1 to 10. But that's easy, but if you have a bigger set, it can be difficult to count. So hence, we use the fundamental of counting principle. And when we talk about repetition in the counting context, if I have to form a password using 3-digit numbers, I can use 555 as my password. But what if I don't want to repeat digits? I cannot use 555. I can use, for example, 542. I've not repeated any digit. So that's what we talk about repetition in counting principle. Great. So what is a sample space and what is event? A sample space and probability, if, for example, I have a coin, if I flip a coin, there are 2 possible outcomes. What are those outcomes? Is it tail or head? So tail and head are my sample space. And what is the size of sample space? Is 2 in a class of boys and girls. If in that class there's 30 of you, the sample space is the sum of boys and girls in that class. Are we together? That's the sample space. Then an event, we'll talk about, when we talk about an event, let's go back to an example of a classroom with boys and girls. So the probability of choosing a girl, it's an event. The probability of choosing a boy, it's an event. Are we together? That could be an event. Fantastic. So let's look at some of our probability we've done previously, okay? Inclusive, mutually exclusive event. What is that? So if we have 2 inclusive event, which is A and B. It's an event. We've defined what is an event. So the 2 events have a common outcome. Are we together? There's a common outcome between the two events. If we look at subjects, so I could be taking, let's say, maths and science, okay, something of that nature. There's an intersection between the common thing, the two events. So this would be something like the probability of A and B. So the probability of A and B is the probability of A plus the probability of B minus the intersection. Are we together? So that will be mutually exclusive events. So if we have two mutually exclusive events, A and B have no common outcome. Are we together? So this part becomes 0. Are we together? Okay. So one example is taking physical science and math literacy as a subject. Sometimes it's not allowed. So you can't take, two cannot happen simultaneously. Okay. So if that's the case, which is exclusive, if this part becomes 0, then the probability of A or B is probability of A plus the probability of B. Great. And what about complementary events? Events which are mutually exclusive events that together contain all outcome in the sample space. For any two complementary events, so this means not, the probability of not A, it's 1 minus the probability of A. Or also the probability of A is 1 minus the probability of not A. What does that mean? If the probability that it will rain today is 50%, what is the probability that it won't rain? It's 50%. It's 100% minus 50, which gives us 50%. So the two events are complementary. Okay. What about two events which are statistically independent? So events which are statistically independent, the probability of A and B is the same as the probability of A times the probability of B. And statistical independent, remember, the probability of A occurring does not affect the probability of B occurring. Okay, those are statistical independent. Okay, so then from there, we have to remember our fundamental principle of counting. Okay, what does the fundamental principle of counting say? If there's M way of doing something and N way of doing something, then there is M multiplied by N ways of doing both together. Okay. So the fundamental counting principle states that if there are N A outcomes in an event A and N B outcome in event B, then there are NA multiplied by NB outcome in event A and B combined. Are we together? Fantastic. So we've indicated that we'll focus on application of counting principle. Okay. So application of counting principle in calculating probabilities. What is probability? Okay. How do we calculate probability? Let's look at this following definition. Okay. So to determine the probability that an event occurs when the total number of arrangements of a sample space S. So S is the sample space S. Are we together? And the total arrangements for the event E, so those will be the total arrangement, which is E, are very large. We will use the fundamental counting principle to determine the total numbers of arrangement. So we will use, so we know that if we have a die and we roll a die, what is the probability that one will occur? Because there's only one, the event is one. There's only one in a die. But the sample space is 6 because we have 1, 2, 3, 4, 5, 6. So the probability will be NE, which is 1, and SNS, which is the total sample space, which is 6. It will be 1 over 6. So we have used counting, but a simple counting, because I can count how many, the sample space in a die, and the event in a die. But if you have a large number, it will be difficult to count. We'll have to use the fundamental principle of counting. Okay, so we will use the same formula, but what will differ, we'll combine this with fundamental counting principle. Okay, guys, when we come back after this break, we'll look at how we really apply the fundamental principle of counting and probability theory. See you shortly. Hello there, welcome back once again. So we've looked at probability definitions and the fundamental principle of counting principle, which is if I have M way of doing something and N way of doing something, there's M times N ways of doing both M and N. Are we together? Now what are we going to do? We'll look at one example on counting principle. Then after looking at that one example of counting principle, and really because our focus is applying counting principle and probability, let's look at what we have. So here we're going to apply our fundamental of principle of counting principle. So there's an example. So the digits 1, 2, 3, 4, 5, 6, 7, and 8, and 9 are used to form a 3-digit code. Are we together? For example, I can start a code which is 5, 6, 7, 2, 1, 6, so on. So you only have numbers 1 to 9, and you want to start a 3-digit code. Could be a PIN for your cell phone or whatever. Okay. So make sure you understand the question. The question, we're starting a code which is a 3-digit code. Very important. You read the question. We understand that. Now the question is, determine the number of difference codes that can be formed if repetition is allowed. We have defined what is repetition initially. So it implies, because we have a 3-digit code and we can use 1 all the way to 8, we are allowed to use 111. Okay. How many pins are there? That's the first question. The second question is, if a code of greater than 500 and repetition is not allowed, okay? So we have to start a code of greater than is not allowed. So we cannot have a code like 679 because 679 is more than 500. Are we together? But I can have 123 because that is less than a 500. Then our last question, if the middle digit is 5 and repetition is not allowed. So I want to start a code, a 3-digit code, but the middle number must be 5. Then I can put any number first or the last digit. But now repetition is not allowed. That's very important. So I cannot have 1, 5, 1. Because if I have 1, 5, 1, I've repeated 1. Okay, great. Think about this. What do you think if I use repetition for a code? Will your password be secured? Okay. Now let's see. So the first question, determine the number of different codes that can be formed if repetition is allowed. So if repetition is allowed, so the number of different codes that can be formed will be 9 times 9 times 9. Why 9 times 9 times 9? Because I have 9 digits available from 1 to 9. For the first position, I can use 9. For the second position, I can still use 9 because I can repeat. For the second position, I can still use 9 because then my answer will be 9 times 9 times 9. That will be the total number of digits, 3 digits, if repetition is allowed. Fantastic. Okay. Now let's look at our second question. Okay, so the second question will still have to form a 3-digit code, and some restrictions are given to us. Let's read the question again. So the digits, which is 1 all the way to 9, are used to form a 3-digit code. And this is an example of a 3-digit code. Okay. So determine the number of different codes that can be formed if the code is greater than 500 and repetition is not allowed. So the restriction here is that our code has to be more than 500, but we cannot repeat the digits. Are we together? So we cannot have 555 or 666. We can't use 66 twice or 9 twice or 3 times. We cannot repeat the digits. And I hope it's not the first time that you see a code where you are restricted. I mean, when you create the password online, they will probably say, we need a letter, numbers, and a character, or use caps. And the reason for that is just to make your code more secured, okay, against hackers or other criminal activities, okay. Let's see how can we form passwords here. So the first digit could be what? 5, 6, 7, 8, or 9. Why 5, 6, 7, 8, 9? Because if we can start with 5, 6, 7, 8, or 9, we'll know that that 3-digit password will be more than what? A 500. Are we all together? So that's what we know. Are we together? So the number of different codes that can be formed, remember, no repetition. Are we together? So we can start with the following. So for the first position, why do I have 5 there? Because I can use 5, 6, 7, 8, 9. I have 5 choices to choose. Okay? I have 5 ways to choose. Are we together? We'll put 5 there. Are we together? Then the first position, I've already used 5. Then the last 2, I can repeat. No repetition. It's clearly there. You cannot repeat because it stays there, no repetition. So I only have 8 left because no repetition allowed. We've chosen 1 digit from the 9, then we can choose what? We can use 8. Are we together? Then the last position, we have what? Left with 7 choices we can choose because first position taken, second position taken, then we have to multiply by 7. And if we multiply 5 times 8 times 7, we get 280 password can be formed. Fantastic. Hope this makes sense. Now let's look at our third example. What does our third example mean? Still the same problem, but with a restriction, but a different restriction. So we still have digits 1 to 7, 1 to 8, and 9, which is the last one, which is 9 digits, are used to form 3-digit code. So determine the number of different code that can be formed if the middle digit is 5 and repetition is allowed. Are we together? The first one, no repetition. But here, repetition allowed. Repetition allowed implies I can use the digit more than once, or I can even use it for the 3 positions. But the requirement here is that the middle must be 5. Are we together? Let's see what we get. So the first digit could be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Because repetition is allowed. I can use anything 1 to 9. But the second digit can only be 5, guys. Only 5 I can use because 5 must be in the middle. And what about the third position? Repetition allowed? I can still use what? Any number from 1 to 9. Okay, and this is what we get. What do we get? We get 9 times 1 times 9. Why do you get 9 times 1 times 9? Because the first position, we can use all the numbers from 1 to 9. We have 9 choices to choose. The middle one, which is the 1, because 5 must be in the middle, we can only use 5. There's only one 5 we can choose. And the last position, because repetition is allowed, we can use all the 9 numbers. Are we together? And if you multiply this, what do we get? We get 81. Okay, so same question. What if repetition is not allowed? What will change? 5 is still in the middle? What will change? What do you think? Because repetition was not allowed. So you will still have 1. Okay? And what will we have the first position? Because we've used one number, we'll have 8 there. And for that 9, we'll have what? 7. Are we together? That's what will change. Are we together? If repetition allowed and repetition allowed. It's very important that you look at that. Okay? So this is what you get, and you'll multiply and you'll get your answer. For now, we'll take a short break and we'll see you shortly. Hello out there, welcome back. We're still looking at application to counting principles, okay? And remember, when you're doing a counting principle, remember we have choice with repetition and choice without repetition. Just pay attention to that, repetitions without repetition. And now we apply that in probability. Let's see what kind of a problem we have for you. Okay, so there is a problem. So I encourage you to read the question very carefully, okay, and really understand that before you look at the questions. So every client of a certain bank has a personal identification number, which is called PIN, okay, which consists of 4 random digits, very important, chosen from 0 to 9, okay? Make sure you understand the question. We're talking about a PIN, which is 4-digit, okay, number, but those digits are chosen from 0 to 9. Are we together? Makes sense. Now, what does the first question want us to do? How many PINs can be made if the digits can be repeated? Digits can be repeated. It implies I can use 9999. And so on. I can use 555 4 times because I can repeat the digits. The second question, how many pins can be made if digits cannot be repeated? So the second one now, you cannot repeat the digits. If I've used 5, I cannot use 5 again. If I've used 9, I cannot use 9 again. So you cannot repeat the digits. Then followed by what? If a pin, this is the application of probability now, if a pin is made by selecting 4 digits at random and digits can be repeated, okay, what is the probability that the pin contains at least 1 8? Okay, interesting question. Then our last question, if a pin is made by selecting 4 digits at random and digits cannot be repeated, what is the probability that a pin contains at least 1 8? Are we together? Fantastic. Let's see how we can tackle this. So it's still the same problem. Okay, remember we're working with 4-digit pin and we have to choose digits from 0 to 9. The first question, how many pins can be made if digits are repeated? We definitely can have. If digits can be repeated, we have 10 digits. Remember, 0 to 9, you have 10 digits. Okay, because we're counting 0 all the way to 9, we have 10. If you're counting from 1 to 9, you have 9 digits, but we're including 0 as a digit. Hence, you have 10 digits. So 10 digits, we have to choose from where? 0 all the way to 9. You have to choose 4 digits. Then the number of possible pins. So the first position, we can choose what? 10, because we have 10 choices from 0 to 9. And the second one, we also have 10. And the third one, we have 10. And the fourth one, we have 10. And you multiply, you get 10,000. Or you can leave your answer as 10 to the power of 4 in an exponent's form. Here, we could repeat the digits. Okay. Let's look at the second one, which actually restricts us. We cannot repeat the digits. Okay. So still the same problem. Remember, we're talking about a 4-digit pin, okay? And from where? From which numbers? 0 to 9. Very important. How many pins can be made if digits cannot be repeated? Very important. We cannot repeat digits here. So let's look at this. If digits cannot be repeated, you have 10 digits for the first choice. Are we together? Then 9 for second choice, 8 for third choice, and 7 for the fourth choice. Are we all together? We have 10 for the first choice. Are we together? Followed by 9, 8, then 7. And by fundamental principle of counting, we multiply those numbers together. Okay, let's see what we have there. There we have. Therefore, the number of possible pins will be 10 because we have 10 digits to choose from for the first. Then we have 9 because we cannot repeat. We already used 2. We have 8 to choose from. Then we have 7 to choose from because we already used 3. Are we together? And if you multiply, that's what we get. Okay. Those are the total numbers of pin if we use digits from 0 to 9, and repetition is not allowed. Okay? Just remember to pay attention. Repetition allowed and repetition not allowed. Fantastic. Okay. Let's look at this third and the fourth, where actually contains some probability. So the third question, we're still dealing with a client from a certain bank, okay? So remember, we're dealing with a pin which consists of 4 digits which are random. And where do we choose the 4 digits? From 0 to 9. In 0 to 9, we're talking about 10 digits, numbers. So if a pin is made by selecting 4 digits, okay, at random, and digits can be repeated, very important, repeated. Digits can be repeated. What is the probability that a pin contain at least 1 8? It must at least have 1 8, your pin. So what is the chance of choosing that pin? Okay. Remember the probability, it's what? Okay? It's the event over divided by the possible outcome. So we'll have to use our counting to calculate our event and an outcome, and able to divide both and calculate the probability. So firstly, we'll have to calculate how many pins with at least 1 8. That's what we have to do. And let's see how we can do that. So, if 8 is in the first place, are we together? Then the number of ways of arranging other 3 places is fine because we can repeat digits. So if we use 8 in the first digit, we still, okay, we have 10. Then we have 10 times 10 times 10 because remember, repetition is allowed. Are we together? If 8 is in the first place, the numbers of ways of arranging other three places. Okay. Now, what about if 8 is in the second place? If 8 is in the second places, the number of ways of arranging other three places will have what? 10 times 10 times 10, which is also 10,000, remember, because repetition is allowed. Then lastly, if 8 is in the third place, the number of ways of arranging other three places will be 10 times 10 times 10 also, because we have 10, 10, 10, which we get what? 1,000. Okay. So if 8 is in the fourth place, the number of ways of arranging other three digits will be 10 times 10 times 10. Are we together? Which is 10,000. Are we together? Are we together? Because if you choose 8, it's only 1 8. Are we together? Then times 10 times 10 times 10. So we're thinking of 8 could be in the first place, 8 could be in the second position, 8 could be in the third position, 8 could be in the fourth position. So we're just arranging three digits. Are we together? Fantastic. Then what do we do here? So the number of ways of selecting digits will be 1,000, 1,000, 1,000, 1,000, which is give us 4,000. Are we together? Because if you're 4-digit, 8 can be in the first place, second, third, or fourth. So there's 4,000 ways of doing that. Okay. Then now, how do we do the probability? Let's look at that. So the total number of arrangement in a set as calculated in the question 1 was 10,000. Okay, remember, which was 10 times 10 times 10, because it's 4 digits, and we can repeat, which was 10,000. Now, therefore, the probability that a pin contains at least 1 8 will be the 4,000 divided by a 10,000, which gives us 2 over 5, or 0.4, which is approximately 40%. Read together. This is an interesting question. So our fourth problem, okay, which is similar. So let's see what is required here. So we're still dealing with a pin, okay, which consists of 4 digits, okay, chosen from where? 0 to 9. Okay, we're still dealing with a digit, 4 digits, we choose from 0 to 9. What is the question here? If a pin is made by selecting 4 digits at random, and digits cannot be repeated, can you see, very important, digits cannot be repeated here. What is the probability that a pin contains at least 1 8? So we cannot repeat the digits. Okay, let's see. So if 8 is in the first place, okay, we have to think of 8 being in the first place, then the number of ways of arranging other 3 digits will be 9 times 8 times 7. Because if 8 is in the first place, it's only 1. So I didn't include that 1. So it's 1 times 9 times 8 times 7. Because we cannot repeat the digits. Okay. Then we think about what if 8 is in the second position? So if 8 is in the second place, the numbers of arranging, okay, other 3 places will still be 9 times 8 times 7, because we cannot repeat digits. Similarly, if 8 is in the third place, the number of ways of arranging other 3 places will still be 8 times 9 times 8 times 7, which gives us 504. And lastly, if 8 is in the fourth place, the number of ways of arranging other 3 places will be 9 times 8 times 7, which is still 504. Okay, then which give us what? So the total numbers of selecting a digit will be 504 and 504. You add that 4 times, which give us 2016. Are we together? But the question was asking about the probability. And how do we do that? So the total number of arrangement in the set is calculated also in question 1 was 10,000, was 4 pin, where what? Repetition allowed. Agreed? Which was 10 times 10 times 10. Are we all together? That there was a total sample space, which we had from the question 1. Now, a pin containing no repetition and numbers and at least 1/8, which is what we have, 2016 divided by 10,000 from our question 1, and we get something close to 20%. You can leave your answer as a fraction or decimal or a percentage. Okay, fantastic, guys. Hope you enjoyed. So, hope to see you after the break with more problems. Welcome back again, guys. Okay, we're still looking at application on counting principles, and we really encourage you to work hard at home. And how you do your mathematics, you do your mathematics with a pen and paper. You don't just observe, and try some of the problem with us. Okay, that's important. And sometimes it's okay to be challenged, not to get the answer correct. It's okay, but what is important is to persist and keep working hard. So we're still on counting principle, okay, and we're working on with our probability. Remember your fundamental principle of counting. And when you do the problems, remember choice with repetition, very important, and arrangements without repetition, very important, because you miss the repetition or without repetition, that has a different interpretation. With repetition and without repetition, very important. Let's look at what we have. So another examples, we're going to look at number plates. So the odd number plates on a car consist of 3 letters, agreed? Okay, 3 letters of alphabet. But this excludes vowels and Q, okay? So on number plates, we don't use the Q and the vowels, okay? Because I think Q might look more like 0, okay? So we don't use Q and the vowels. Then the number plate will be followed by what? By 3 digits. What are those 3 digits? Which is 0 to 9, okay? So remember, it's a number plate, consists of 3 letters, okay? Then after that we have 3 digits, 0 to 9. For letters, we cannot use vowels and the Q. Okay, that's right. Make sure you understand the question. That's very important by reading it. So for a car chosen at random, what is the probability that the number plate starts with Y and end with an odd digit? So the question is, if I have to select a car at random, what is the chance that the car number plate will start with Y or an odd number? Okay? What is an odd number? Have you thought of an odd number is? It's a number divisible by what? 1 and itself. Okay, let's see how we can tackle this. So, to identify what events are counted, the number plate must start with Y. Are we together? So there's only one option for the letter because it must start with Y. If it ends with an odd digit, there are 5 options for the last digit, which is 1, 3, 5, 9. Okay. Then from there, Let's see. So we have to find the number of events. For the second and the third letter, there are 20 possibilities. Okay, remember we have 26 letters in the alphabet. We have to minus 5 vowels, and we have to minus the Q, that we're only left with 21 letters. We together, that's where we are. Okay? Said a number plate that starts, remember, with Y and end with an odd number. First place, there's only one Y, we can use Y. Are we together? But for letters, we have to minus vowels and Q, we're left with 20. Odd numbers, we said it's 1, 3, 5, 7, and 9. So we only have 5 odd numbers. From where? From 0 to 9. Great. So there are 10 possible, if we look at this now, there are 10 possibilities for the first and the second digit. Okay? Which is 0 all the way to 9. So if you look at this now, the number plate will be 1, Y1, because it must start with Y. We only have one Y. Then for the second position, it must be a letter. How many letters are there? We know there is, yes, 26. But we minus the Q and 5 vowels. We're left with what? 20. Are we together? Then there's another letter also, because we need 3 letters. A letter which is 20, letter which is 20. So you have 1 times 20 times 20. Then followed by what? 3 digits. But there's a restriction for a digit, that the last one must be an odd number. But the first 2 digits does not really matter. But how many digits do we have? We have 10 digits. So we can have 10 there, and we can have 10 there. But for the last one, because we must end up with an odd number, or odd number, which we have 5 odd numbers. Are we together? Then we multiply this. And what do we get? We get 200,000. So there's 200,000 ways of choosing that. What? A car registration that starts with Y and ends with an odd number. Okay. What was the question again? Let's see that. So we're talking about all number plates in the car consist of 3 letters of the alphabet. Remember, excluding the vowels and Q are formed by what? Any 3 digit, which is 0 to 9, for a chosen car at random. What is the probability? The question is, what is the probability that the number plate starts with Y and ends with an odd number? So the question was about the probability. How do we calculate the probability? Step 3 now, to find the probability. So we know the numbers of different number plates. Okay, so the number of different number plates, it would be what? 20 times 20 times 20 times 10 times 10 times 10. Because we have 20 letters we can choose, another 20 for the second position, another 20 for the third position. And for numbers, we have what? 10 times 10 times 10. Are we together? And if we multiply this, what do we get? We get 8 million number plates. Then, is this the answer? No. The question is, what is the probability that the number plate starts with Y and ends with an odd digit? So what do we have to do? So the probability, we have to do what? The number plate starts with Y and ends with an odd digit. So what do we have to do? The N means the number of number plate that starts with Y and ends with an odd digit. We have already calculated that. Over the total numbers of number plates. So what we had? We had 200,000 divided by 8 million. Are we together? You simplify that, what do you get? You get 1 over 4. You can leave your answer as a fraction. That's the probability. Are we all together? Makes sense? Okay. So let's look at the summary of what we looked at. We have looked at the fundamental principle of counting, which means if I have M way of doing something and N way of doing something, I multiply those, I find ways of doing. Then arrangement with repetition. Just pay attention to that. Without repetition, you cannot repeat. Okay. With repetition, I can repeat the letters. And this can be tied together into probability. Are we all together? I hope this makes sense, guys, and you enjoyed. And we hope to see you soon. And this is goodbye from us.